Okay, so now let's talk about the quiz. And even though, it was a quiz, so it was not an exam, it was not heavily weighted on your grade, but it was very helpful for me to understand what are some of the things that maybe there are gaps in maybe the way I'm saying, or maybe the way that you're understanding, but definitely something we want to address regardless of where the gap is. And I just want to walk through some of that. I will get your grades in maybe tomorrow, maybe today, maybe tomorrow. But I have already graded it, and I just want to shift gears and show you. Just close this on the new window. Okay, so as a big R nerd that I am, I actually brought in your grades into another script that I'm not sharing with you, just to explore a little bit of this data, right? So first, I just want to show you, this is your density plot of all the grades among all of you. So we had a couple people that nailed it. The majority of you were perhaps between 85 and 90%. And then we had some that did a little bit less than that. Again, no, if you did not do as you wish, don't worry. This is just a quiz, even though perhaps it felt like an exam, it's not. However, what we cover here are things that I may ask in the midterm, which we have not scheduled yet. We have to do that, but I just want to make sure that you do pay attention to what we're going to go through here, and not simply because I may ask them again, but because these are important topics for you to know in your career. So I just want to make sure we have these concepts pretty well understood. And if as we go through, if something's still not clear, please let me know, or maybe afterwards, I can give you some more resources to read. We can talk more about it. So we make sure that you understand this. Okay, so this is the overall grade, right? The distribution of that. This is the average point. So the way that I graded this is each question was worth 100%, and then in the end, your total grade was just an average of all the questions. So here's just the average across all of you for each one of the questions. We see perhaps that some that created more confusion here were, question 7 and 8, which let's see. 7 was, I think, where a lot of people missed was what was the unit for the UTM NAD83. A lot of you missed that, or not a lot of you, but the ones, that was the issue with that question for the ones that missed it. And also understanding that in itself also leads into the next question, which was which one of the two between WGS84 and UTM you need for distance-based operations. So if you didn't know the unit of NAD83 UTM, then that answer was not as clear to arrive at for the following question. But so we see here that some confusion with that. I guess there was every question had points that I can clarify what was the right answers. That's what we're going to do next. And also, so that this is the average across all of you. This is the distribution of the grades for each one of the questions. So if you think of it, like if all of you would have gotten 100%, this would be like very flat in the beginning. So this is from 0 to 100% for each question, the distribution across all of you. So if all of you got 100%, this would be like a pretty just like straight line, and then goes up all the way when it comes to 100%. So here we really see again, question 2 had some people that missed it. Question 6, 7, 8, we had this bump here showing that a lot of people actually missed those. And question 10 question 10 was about the project. We also had some misunderstandings there. Okay, so I want to talk about each one of the questions now. First, the first question, is this file geospatial? The file itself, of course you didn't see the read part of the code, so we didn't know what the file was. However, that file itself was a CSV. So the file is not geospatial, right? CSV doesn't have to be geospatial. However, we can bring in a CSV, and in this case, it was a CSV that had coordinates that we could then use to turn into a geospatial file or object. And when I was reading this, I noticed that a lot of you, like some of you answered saying it was, others answer saying it was not. And then I really, read the question again, and I think I wasn't clear on my question. So as long as you answer whatever you did, if you said it was or was not just spatial, as long as you explain why you thought what you were saying, and that made sense, you got it right. So most people got this right because I was accepting both answers, I guess, at that point. And this, again, is just it may seem a little bit silly to be thinking about this, but it's really, I think it's important for us to understand, because there are files, right, on your system like CSV, shapefile, GeoJSON, but there are also objects which are related to those files, but that can be, another layer of understanding, as far as you can bring a CSV and turn that into an SF and then export that SF as a shapefile, right? So there is like the file themselves, but also how they're interpreted in R and how R treats them are two different layers. Okay, so question number 2. Well, I guess any thoughts or questions about question 1? All right, I don't hear anything. So question 2 was, what function we have to use to transform that CSV at that point, which in R is just a data frame, into an SF object. STSSF was the correct answer. Some people answer ST transform, which I can see how you would think that, because the question was asking how you transform it into an SF object. So that can be confusing. However, just to refresh your mind, ST as SF takes a data frame and transforms that into SF. ST transform takes an SF object already and transforms the CRS, right? So it takes the CRS, let's say WGS84, and transforms that into ETM. So two different functions with two different purposes. And then I think this one, everyone got it right. Get that once you transform using STSF, it is a vector, and it is of type point. I did not ask you to provide me what type it was. So if you just said vector, you got it right. All right, question number 4 was really interesting because, I guess some of the things I was asking you to tell me if it was vector or raster were pretty straightforward, and others were not as much. So field boundary was vector. I think most of you got this right. And it is a vector of type polygon. I did not ask you to say if it was polygon, line, or point, but it is of type polygon. And the main difference between a polygon and a line is that the line does not close, right? So if this shapefile would have started, so if you think of the outline here being the boundary, if the boundary for some reason would not have closed, it would be like stopped here and the beginning was up there, that would have been a line, which makes no sense in our case. No boundaries are defined that way. They're always closed, they're always polygons. But lines could be things like rivers, or maybe, I don't know, things that are linear in space that don't have to close, and that's how we show them in a GIS. Okay, gridded soil samples. This was a really interesting one that also I think I was not clear on my question. So I accepted both answers. If you said it was vector, I accepted. If you said it was raster, I also accepted. However, I do want to make the point here that at least what I intended to say, maybe is not what you interpreted, and because of me being confusing, but a gridded soil sample layer is point, right? So if you think of this is just one example for the same field that we're working with. Even though you have to create a grid, and that grid, again, could be raster, could be vector, it depends. The grid is really the trickiest to say, is a grid raster or vector? It could be both. In reality, all of it could be both, but the grid is perhaps the one that is most confusing. So the grid could be both, but the gridded soil samples themselves have to be point, because you go to that field and you collect that sample from a point and you take a GPS coordinate. So you can think of it as each one of these points that you're seeing being the location where a soil sample was taken, right? So because of the way that I wrote this, maybe it wasn't super clear. I accepted both answers, but really the correct one is that it would be a vector of type point. Even if afterwards you bring in and you interpolate and then you create a raster, yes, but that was not what I was asking, right? I was asking about the gridded soil samples themselves. Any questions or thoughts about this? All right, I'll just keep going. So UAV imagery, raster. County boundaries, it was also a vector of type polygon, right? Because the boundary of that county is closed, so it's not a line, it's a polygon. Now, smartphone picture and satellite imagery, at least the ones that we've been talking about in class, are always going to be raster. Maybe the one case where a satellite imagery is not raster is if you're working with LiDAR, because you get point data out of that. We're not going to be working with LiDAR data in our class. That's not going to even be mentioned much. So as far as we're concerned, and we are more familiar with, any image is raster. And again, if anytime anyone has any questions, need clarification, please let me know, jump in. We're here to clarify that. Okay, question number 5. Which columns needed if you wanted to apply the filters as we did in class? All I was looking for in this question is that you just told me the column names, right? So with speed and dry yield, if you told me those, I mean, even if you told me like dry yield without underscore, I'm not that picky. I know what you mean. That's what I was looking for, and that was the right answer. Okay, question 6 and question 7. We really need to get this understanding, and at least in class, I thought I was mentioning this every time it was coming up. So by repetition, I thought I was making this clear, but I realized that was not the case. So WGS84 is a geographic information system or coordinate reference system that uses degrees as the units, right? So it's degrees longitude, degrees latitude. And the EPSG for that is 4326. That's what we've been using in class. That's what you've been seeing in our codes throughout. So I guess most of you got this one right. So maybe the confusion was not necessarily here. But the next point is important. Why did we in class transformed our layers from WGS84, which is again the most common CRS that is used. So if you go and collect GPS data, if you go on Google Maps, if you go in many of these services, those coordinates are going to be WGS84. So that's the most common one. Now, why do we, in our case, did we transform from WGS84 to NAD 83 UTM Zone 16 North? It's because that transformation changes that projection from geographic, so from degrees, into meters. So now, if we want to do distance-based functions like interpolation is, or buffer, or things that depend on the distance, we have to have those units as something that is measurable in a distance, right? I mean, I cannot say, hey, I am 3 degrees apart from you. That makes no sense, right? I am a feet or 10 meters, right? That makes sense. So we have to have them in a measurable unit of distance when we do distance-based approaches, like, again, boundary, or buffering a boundary, or interpolation, or maybe others that we haven't used yet. So NAD 83 UTM Zone 16 North, the EP, or I guess I have a typo there, but the EPSG is that we've been using in class at least is 6345. Some of you provided me a different EPSG that I went back and checked, and that was actually a valid EPSG for the same CRS. So I accepted that. It didn't have to be exactly the one that we were using in class. If you gave me a different one and it made sense, I accepted that answer as well. And again, just want to say this one more time to make sure that we get it. WGS84 is geographic, the units are degrees. Any UTM, and in this case, NAD 83 UTM Zone 16 North, because that's zone specifically for where this field is in Georgia, is in meters, and that's what we need then to use when we do distance-based approaches. Okay, so I brought in our boundary, and I just wanted to show you here. So this I was not expecting you to do this. This was not part of the question. This is something I did extra just to show you why we need in meters rather than degrees. So what I did here, I brought in our boundary for this field that we've been using already, so you're familiar with that. And I just printed that below. I call that WGS84 because that's the way it comes in already. So if we see here, when we print it, it says geodetic CRS WGS84. That's how we know what it is. And then I did transform it using the function sttransform, again, to change the CRS. I changed the CRS to UTM, and then I saved that into an object called boundary UTM. So now I have the same boundary. One is geographic, WGS84, the other one is projected in UTM. And then I printed the UTM, and we can see now projected CRS, NED 83, UTM zone 16 north, right? So that's what we needed. And then I created a buffer of each one of those boundaries, just to show you here the concept, right? So a buffer based on the WGS, doing a buffer of -20, negative buffer in this case, and then a buffer on UTM, using the UTM and doing -20 as well. One thing for you to notice is when I did the buffer based on the WGS84, and especially the negative buffer, my bounding box was coming as an A. So remember, bounding box is like the imaginary box that comprises the entire layer that you're doing. My bounding box is an A. However, when I do that, the same ST buffer function, the same distance, but using the boundary in UTM, I do get a valid bounding box. I tried to show this in a plot. However, the way that this works in a plot is there is no plot really for the buffer WGS. It doesn't plot anything because it's all in A. But the reason why it's all in A is because we're doing a distance-based operation on a layer that's in degrees. So remember, every time we do distance-based, it has to be on metric or maybe feet, but it has to be a unit that is a measure of distance. Any questions about that? Okay. So let's go to the next question. I did here import data you did not have. So in this case here, you did not need to type a code itself. I mean, you did not need to like give me the code that you would use in R exactly as we did in class. All I needed from you, I was just asking you, if I give you an SF object and I want to color points according to X column, what would be the code for that? So I accepted a few different versions of this, but really it was, you had to start with ggplot, right? That's how we start every plot. And then because it is an SF object, you have to use geom_sf function to plot it. So some of you gave me geom line, some of you gave me geom density. Those were not accepted because that's not how we would plot this. I mean, we could plot an SF object using geom density, for example, but that's not, but when I told you that I wanted the points to be colored according to yield, then you cannot do that with the geom line or geom density. That doesn't make sense. And then another thing that I looked for in this answer is the part that I say I want the points to be colored by yield in pounds per acre. Remember, every time you're mapping something aesthetic from the plot, from your graph into a column, that has to go inside AES. If it's outside, it does not work. If it's outside, it could be color equals red, for example, but not color equals column name. So this is different versions of this is what I was looking for. Some of you gave me the scale fill Viridis. That was fine. I mean, this is the minimum I needed. If you gave me extra, that was fine. Yeah, so I just had here an example showing that, yes, for the same data frame, which is SF, I can do a geom density. But when the question says that I want to color the points by yield, I mean, there are no points here. How does it doesn't really make sense, right? Okay, so and the last one about the projects, or how would you set up an RStudio project? So we probably have made 4 different projects at this point with the setup of folders and all that and changing files to the right subfolders. And what I was looking for here, and I really want to make sure that we get this because for the final project, I'm gonna, so for all these different assignments and this quiz, I'm being very, very lenient towards like, okay, maybe you could have made this look better. Like one example is some of you, when you render, you don't have the questions all like that. You have some that are like close together and they don't appear. And I guess like what I'm trying to say is you're not losing points yet for those things. But as we continue doing the same things over and over, I will start becoming more picky about I really want this to look sharp when you send me. And the RStudio project, even though it doesn't have anything to do with how the HTML looks like in the end, but it is one of the things that we've been doing maybe a handful of times already in the course. And I really want you to get this right, because when you send me the final project, you will send me not just the HTML, but the entire folder structure. And I'm going to be grading every single point, including if you got the project set up properly. Some of you, so what I was looking for here is, let me just perhaps open one of my projects again. So this is the structure of a project that we've been talking about in the course, right? So you have a main folder. So in my case, my main folder is called 04 Monitor. Where that folder is doesn't really matter. In our class, we're saving that inside of our class. At least in my class folder is 2023 Spring Advanced Precision Ag. I have that 04 Monitor right there. So that's my main project folder. If I go inside of it, I have a code, data, and output subfolders. And here's a point that maybe a handful of you got confused about. When we go then on RStudio and create the RStudio project, we save that at the main level or at the higher level of the main folder, right? So it is right next to code, data, and output. If you're not seeing your project at this level, if it is inside code or data or output, it's in the wrong place. It has to be at this level here. So most of you got this right. A few of you suggested saving the rproj or creating the project inside of code. That's not where it goes. The code just goes QMDs, HTMLs, R Markdown files, R scripts. No project goes into code. So just wanted to make that clear. And yeah, so I guess those, I just wanted to go through all these because these are small things, right? But they all add up to the cumulative knowledge we're creating in this class. And if you have a gap in understanding some of these, and then you go on and do more complex things, maybe at some point you're gonna get lost without knowing some of these bases. So again, it was just a quiz. It's not worth a lot of points, but some of these questions may come back. Some similar questions may come back. I may ask you how do you transform CRS, from what function do you use? Things that we've been doing a lot in class, and as long as you're following along and paying attention to what we're doing, you should be getting these things already. If something is not clear, always let me know. We can always chat. I always want to make sure that you're understanding. Before we finish for today, I do want to take attendance. So let me go to GitHub. All right, I just created the issue, so go ahead and claim your attendance if you're watching live.